There are a million data points you could get for your farm. Soil tests, tissue tests, yield maps, satellite data, the list goes on. The question is, which data is going to be most useful to you as the farmer? I can tell you it's not the one with the most data points. It's the one with data that you'll actually put to use. Hi, I'm Lacey. I'm a UX designer who specializes in making agronomic data clear and usable. Today, I'm going to dive into one type of agronomic report, a plant sap analysis. This is a form of precision ag that measures old leaves and young leaves to tell us if the plant is getting the nutrient it needs as it grows. Just like humans, plants need a balanced diet to grow strong and healthy. Strong, healthy plants are more resistant to disease and they're more productive. One of the great things about sap analysis is that it tells us if the plant is getting a balanced diet of nutrients even before there's visual signs. So we can catch imbalances when it still looks like this, instead of when it looks like this. Here's what a sap analysis report looks like. Now, I think we can agree that it's very data heavy. The farmer who ordered this is definitely getting their money's worth in raw data, but how can we make this more useful? To start to interpret this data, I first need to understand the nutrients and if they're in or out of their optimal range. The main feature of this report is this bar chart that shows the nutrients found in new leaves and the nutrients found in an older leaf and how they compare to the optimal range. Optimal ranges are different for every nutrient, so I'm comparing each row with its individual context. Every time I switch from row to row, I have to reset my understanding of the optimal range. This constant switching is called comparative friction. Just like physical friction, it slows me down. And worst case, if I'm quickly scanning this report, I'm more likely to read it incorrectly and possibly even jump to the wrong conclusion. What if instead we used relative scaling, where the results are standardized and shown in relation to their own ideal range? Now we can quickly tell whether this nutrient is in or out of balance. It's especially effective at scale when we're looking at a long list of nutrients. We're losing some numerical data in this view, but we're gaining clarity and also, hopefully, reducing errors. The next thing I need to understand from this data is, how much did the nutrient increase or decrease between the old leaf and the new leaf? In the current version, we can see from the bar chart or the numerical values. But how could we distill it down to the most essential message, up or down, and by how much? What if we combined these two lines into one and used an arrow to show directionality and amount of change? Add the optimal ranges underneath, and I can quickly get the essential information I need. Is it in or out of range? Did the nutrients increase or decrease? Add the nutrient names as well as some semantic icons that bring our attention to the nutrients that most need our attention, and we have a scannable, comprehensible report. You may have noticed that there are no numbers in this version. We have deprioritized the exact numbers in favor of quick comprehension and clarity. But what if I, as a farmer or the agronomist, still want to see the numbers? I at least want to know that they're available for me if I do want to see them. And here's where we can bring in the concept of progressive disclosure. This means that we show information only when it's necessary or if the user asks for it. This way we can prevent data overload. We use this a lot in digital products. You can imagine clicking on one of these rows and seeing a page that contains all the nitty-gritty data for something like potassium or manganese. I also think there's one more thing we could do to easily improve scannability. We can group the nutrients into meaningful subcategories. From a little bit of research, it looks like we could group these into cations, anions, trace minerals, and nitrogen. These groupings will help us as we move on to the next stage, interpreting the results and making a customized plan. So far, this has been an exploration of how to improve the current experience of a SAP analysis report by applying UX thinking. The next step is turning the data into action. As I said before, the best data is the data that you'll put to use. So we need a playbook. We need step-by-step recommendations. Thoughtfully designed digital tools can help us understand, here's what's missing, here's why it matters, and here's what to do right now for your particular field. We're also at a technological inflection point. The integration of AI and machine learning into these digital tools has the potential to help farmers and agronomists make management decisions that are site-specific, and it could forecast results that incorporate many different variables, like soil type, topography, recent weather, and even market and economic projections. It can also be a force that democratizes information, so more people can make data-informed land management decisions. I'm excited about this future, and I'm ready to make it happen. If you're working on a project that's making agronomic data clearer and more useful, let's chat.